Greetings, math fans. All right, so this is our last day of this chapter, and we've been doing systems of equations. We did applications, and the last lesson was graphing an inequality, right? And remember, with graphing an inequality, you had to use a dotted line or solid line based on if it was less than or equal to or greater than equal to, and you also had to do shading, right? You shade above or below the line based on whether it's greater or less than. Okay. So today's lesson is actually very similar to that. So today what we're going to do is we're going to talk about systems of inequalities. Okay. And so what you guys need to understand is a system, which we've been talking about a lot, systems of equations, that just means more than one equation. So more than one equation. In this case here, it's more than one inequality. Okay? So here's what we're going to do. Remember guys when we did an equation and I had, you graph something like this and you graph something like that and you said, hey, where do these cross? Right? You would say, oh, that's the solution. So, that might be, 3 comma 3, right? And that would be your solution. Well, now what's going to happen is you're going to shade, because we're doing inequalities, and basically the key is you want to shade both inequalities, and you want to see, just like this one where it intersects, the line intersects, you want to see where the shading intersects. Now we don't really use the word intersects, shading intersects, we basically say where the shading overlaps. So we're going to graph both equations, or both inequalities, and we're going to shade one, and then we're going to shade the other, and where the shading is by both of them, that's going to be the solution to our systems of inequalities. Okay? So why don't you guys pull up your graph paper now, just to kind of talk about that. It's just a little bit easier when you have a nice little piece of graph paper. So if you guys can grab that graph paper, which is just day 7 notes. Okay? And I'm going to go to, let's just come up with a couple of inequalities, okay? So I'm going to say y is, this always does this to me, okay? So I'm going to say y is greater than 2x plus 1, and y is less than or equal to negative 1/3 x minus 4. Okay, so let me move that down just a little bit. Okay, so you're just going to graph these like normal, just like you did yesterday. So I'm going to do is a different color to graph the one equation, then use a different color to graph the second equation, and then the third color, I'll use green to show where they overlap. Okay, so we're going to graph y-intercept of 1 and then slope is 2, so up 2 and over 1. It's a dotted line. So draw the dotted line. All right, and it's greater than. So we're going to shade above the line. Okay? So now let's use blue, and we're going to graph the other one. So it's down 1, 2, 3, 4, down 4. And we're going to go down 1 and over 3. So down 1 and over 1, 2, 3. So it's negative 1/3. And this is going to be a solid line. So we're going to graph it like this. Kind of missed the point there a little bit. Make those points a little bit bigger. Okay, there we go. All right. And then it's less than, so we're going to shade below it. And what you want to do is, let me make this a little bit longer then, is you want to say, where does the shading overlap? All right, so let me move this down just a little bit. Do you guys agree? It's wherever the blue and the red are together. And so if you look, it borders by this blue right here and this red and this area right here. So this area is the solution. That's where it overlaps, and so that's where you're either shaded in, right? I'd like you to write the word solution, something. You need to be able to tell me or show me that where they overlap, that's your solution. Okay? So this, again, it's where the shading overlaps. And that's the answer. Okay, so let's try another one here. Y is less than or equal to -1/2 x plus 3, and y is greater than 2x minus 4. Okay, so let's do the first one in red. So we go up 1, 2, 3, plot the point, and it's down 1/2. That's a solid line. And you shade below the line because it's less than, so we shade below. Okay, cool. The next one is y is greater than 2x minus 4, so let's do that in blue. So we're going to go down 1, 2, 3, 4. And we're going to go up 2 and over 1. And that's a dotted line. Okay, and where do you shade? You shade above. Okay, so here we go, shading above. And where does it overlap? Well, you just look where the blue and the red overlap. So if you want to use colored markers, obviously you're probably using your iPad. So you got 18,000 colors, whatever you need to do. But your solution then is basically right over here. It's the whole area right here. Okay, so that's it. Whatever you want to do to shade it, I don't care. Color it all nicely and write the word solution here. It's pretty easy. So you just graph two different inequalities, but you have to make sure everything is right, okay, because there's a lot of points here when you think about it. You're graphing two inequalities, so you got to get your dotted lines and your solid lines correct. You have to shade correctly, and then you have to tell me where they overlap. All right, that's not bad, right? So pretty easy stuff. Let's do an example of a different kind here, which is similar. But if I said x is greater than 3, y is less than or equal to -1. Okay? So you should know how to do that, right? Let's do the x is greater than 3. You should know that's a vertical line. We've talked about this a bazillion times. It's a vertical line at 3. So 1, 2, 3. And it's a dotted line. And remember, when it's an x equals, there's no above and below. So think logically. It's greater than 3. Do you shade to the left or the right? Well, if it's greater than 3, that means 4, 5, 6 is what I want, right? Because it's got to be greater than 3. And so I shade to the right because it's greater than 3. Okay? And then y is less than -1. So we'll do that in blue. Remember, that's a horizontal line at -1. And that's a solid line. And it says it's less than -1, or less than or equal to, so I shade below. Okay, wherever it overlaps, that's the answer. So here we go. It overlaps right here and here. I mean, basically, you look at the two equations, right? And it's below the blue line and to the right of the red line, so it's right next to it. And anyway, that's, you shade it in. And I shaded in just this box here, but this goes on to infinity to the right and infinity down. So it's basically the whole bottom right corner is my answer. Okay, and that's your solution. Okay, let's do one more. Y is greater than 4. X is greater than or equal to 2. Okay, so we got greater than 4. 1, 2, 3, 4. And it's a horizontal line, and it's dotted. Okay, and I shade where? Above. Okay, and x is greater than or equal to 2. Do that in blue. So here it is at 2, and that's a solid line at 2. And it's greater than, so it's, you shade to the right. Okay, and you can see at the top right corner, that's your solution, right over here. So that's what you shade in. Okay, and you write your SOL, solution. Okay, So that's it. That's the systems of inequalities. But make sure you look for that, right? As opposed to if it was equal. Here, let's just talk about that. If that was equal, and you would graph these, first of all, there would be no shading, and the solution point would be where the lines cross. In this case here, they'd cross here. In this case, they'd cross here, and that would be a coordinate. So this would be 3, -1. And this one would be 2, 4. That would be an answer. Okay, and there would also be an answer blank. There's no answer blank for these because there's a whole area that you're shading. Okay? All right, so that's it for graphing systems of inequalities, and that's the end, pretty much the end of this chapter as well. So hopefully you guys are good to go with the different types of systems, applications, graphing, solving, etc. Okay? That's it, math fans. Have an outstanding day. Adios. Goodbye.